Hi, everyone. You're listening to episode 726 of People Behind the Science. And today we'll be rebroadcasting our interview with Dr. Sarah Bergbreiter, originally released on October 2nd of 2017. Listeners, Sarah is an engineer who builds and studies tiny locomoting robots that are as small as ants. She uses advanced technology both in these tiny robots and also to build better sensors and actuators for larger robots to help improve their performance. And in our conversation, Sarah shares wonderful insights and stories. So listeners, I hope you are ready to sit back, relax, and enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Listeners, today I am looking forward to introducing you all to Dr. Sarah Bergbreiter. So Sarah, thank you so much for joining us on the show today. How are you?
I'm doing great. Thanks for having me.
Excellent. Well, glad to hear you are having a good day, and I'm excited to learn more about you and your work. But before we jump right in, Sarah, I want to tell our listeners just a little bit about who you are and how you got there. So listeners, Sarah is an associate professor in the Department of Mechanical Engineering with a joint appointment in the Institute for Systems Research at the University of Maryland. She received her B.S.E degree in electrical engineering from Princeton University, and Sarah was awarded her master's and Ph.D. degrees in electrical engineering from the University of California at Berkeley, where she focused on microrobotics. Now, Sarah has been the recipient of multiple awards and honors for her outstanding work, including the DARPA Young Faculty Award, an NSF CAREER Award, the Presidential Early Career Award for Scientists and Engineers. And then Sarah also gave a fantastic TED Talk in 2015 if you guys want to check it out. And listeners, Sarah is here with us today to talk about her life and science. So Sarah, we are looking forward to learning more. And we want to get to know you both as a scientist, but also as a person. So can you start by telling us what you like to do when you're not doing science and engineering?
Sure thing. I have a 2-year-old and a 4-year-old at home, so that is definitely a huge part of my life outside of work. So they take up an enormous amount of time, but when they aren't taking up 100% of that time outside of work, I like to do sports. I like to swim a lot. I played water polo in college, so I do a lot of open water swims. I used to do more triathlons. Hopefully, as the kids get older, I'll be able to do more of that in the future.
That's awesome. So now do you have the kids in swimming lessons?
I try. Mm-hmm. The younger one does a fantastic job of it. The older one's still a little tentative, but we're working on it.
Gotcha. What are some of their favorite things to do these days?
Well, they love swimming. So we're just ending summer here. Mm-hmm. We did a lot of swimming over the summer. They just also like Legos, building things, playing typical 2-year-old and 4-year-old things.
Fantastic. I love it. Well, great to get a window into how you spend your time when you're not doing science. But I do want to chat a little bit about your work next. So Sarah, can you tell us how you describe what you do to someone who might not at all be familiar with your field in engineering?
I primarily work on very small robots, and the easiest way to imagine this is trying to understand and build an ant. So that would be kind of the mobile robot version of this. But we also use the same techniques that we use to build that ant and that are used to build things like computer chips to make better sensors and actuators for larger robots that ultimately improve the performance of those robots.
Very cool. And I know on your website you have some images of these robots and there's some videos of them in action, and these are really cool. So it must be easy to get people excited about your work.
Yes, it's no problem to get students into the lab for sure.
Absolutely. So I'm curious now to talk a little bit about what motivates you. You've talked about how you have a lot to balance in your life right now with a 2-year-old, a 4-year-old trying to get out there and be active, as well as manage all your responsibilities at work. So can you tell us, Sarah, what really keeps you motivated? Do you have a favorite quote or saying or force that keeps you going in every day?
Well, I think there's 2 different answers to those questions. What keeps me motivated, I think, are all of the people that I work with. So the students that I work with, my collaborators, I'm always excited to do new collaborations with people that I learn from. So really just kind of learning on a day-to-day basis is what keeps me motivated. The kind of an inspirational thing that is probably what I say most to my students is something that my water polo coach used to tell me, and I think came from Wayne Gretzky originally, that you miss 100% of the shots you never take. And so oftentimes trying new things, try a new technique, see if that works, right? We have some idea if it might work, but I think just spending a little time and trying it is often very helpful.
Absolutely. Well, I love that quote. And I think it motivates people to get out there and try, even if there is a large chance of failure. I think failure is so common in science that you just have to get used to it. So.
Indeed it is, yes.
So now I want to talk a little bit about some of the people who may have had an impact on your career or inspired you. You mentioned this water polo coach, and I think these people can have a big impact on our lives. So are there people who really kept you going and motivated you to pursue engineering?
Actually, I would say my mother is probably the biggest one there. She was actually a computer programmer. And so I think seeing how she balanced family and work was pretty impressive to me. And I'm never quite there, but maybe it's my little kid imagination of all the amazing things that she did. But she was a pretty incredible example to strive toward. But in general, I think all of the people that you encounter through school and through your career, you take little bits away from each of them. So my advisor had an amazing way of thinking about problems and abstracting them and doing these kind of order of magnitude way of looking at things just to get a reasonable answer to start. And I love kind of going through that process with my students. I had a wonderful undergraduate research advisor who actually accepted me into her group, which I think was stunning. And so I always try to encourage undergraduates to get involved in my research as well as a result of that. But everybody that you encounter, I think you take away a little bit from.
I absolutely agree with you. I have so many mentors and role models and people who probably don't even realize I look up to them, who I encountered along my path.
It's countless, yes.
Yeah. So now tell us, was it your mother who originally turned you on to computer programming and engineering and sciencey sorts of things?
Probably. She actually got us involved in trying to teach us how to type and get involved in using early spreadsheet programs and stuff when we were kids. Sometimes we hated it, actually, I'll say, but she at least introduced us to the area. I'll say that my dad is actually a scientist as well, so I don't want to leave him out entirely. I think I grew up in a kind of university town, so just getting to interact with people on a daily basis and getting through summer programs when I was in high school and stuff, all of that really got me involved in science and engineering.
Gotcha. Do you have one memory that really sticks out in your mind of your first experience getting excited about a science or engineering project?
There are actually a couple that I can mention. One was in high school chemistry, and I remember studying the triple point, where you have kind of a gas phase, solid phase, and liquid phase all together. And it basically involved taking a piece of dry ice and shoving it into a plastic pipette and pinching it closed so that you'd get the pressure you needed. And a lot of exploding pipettes happening in that lab. And I just thought that was fantastically cool. But I would say also I got interested in robots from a very early age, just through movies and books. And I remember trying to design a robot when I was about 8 to clean my room, but it was really just a tape recorder in a paper bag that was decorated. So you'd push a button and it would say, of course I will clean your room for you. But of course it never did anything like that. But just a lot of inspiration from all of those areas got me excited about things.
So now that you are successful in building robots, did you ever go back and make that room cleaner?
I have not yet. We still are lacking some of the things that are needed in robotics to make that happen, but it's getting there.
Well, very cool to hear about your scientific beginnings, Sarah. I'm curious to hear a little bit more about how you went from this curious kid getting excited about robotics and engineering and science to where you are today. So were there some key steps along the way that really took you to this point?
Yeah, so actually I was curious about a lot of things. And when I was originally looking at colleges and what I would study in undergraduate, I was thinking about actually engineering or history. And I actually went to a school that I thought would do a good job of both of those, regardless of what I decided on. I kind of took a sophomore level class as a freshman just to try it out and decided I actually did like it. So I ended up with the engineering path.
Sure.
But obviously there are a lot of successes and failures along the way. Plenty of failures in addition to the successes. Those aren't often talked about, but define you nonetheless.
Absolutely. So what was the draw for you to history?
I read a lot as a kid, read a lot of books, and I think history is often trying to interpret things from scant evidence. very similar in some sense to science. You get small peeks into a world and try to understand what exactly is going on. And you can do the same thing with history. And given how history often defines us as a culture, I think it's incredibly important to understand what happened. I also did a lot of work in history of science when I was in graduate school. We were actually required to take an outside minor, and I convinced them to let me do history of science. And I think for me, one of the fascinating things to study in the history of science is how people came to the realizations that they did. A lot of times this is presented to you in introductory physics as Niels Bohr walking along a beach and all of a sudden this brilliant idea pops into his head. But there was a lot of correspondence behind that. There's a lot of discussion among people, and this kind of idea of building on the shoulders of giants and standing on the shoulders of giants, that's what really pushes science forward. And I think understanding that it's not a light bulb moment, or you don't have to be completely extraordinary to come up with these ideas, although certainly many of these people are, really helped me understand how science works and how engineering works.
Very cool. Well, we mentioned you did your master's and your PhD at Berkeley, and this is where you were able to do this minor, which sounds a really cool opportunity. So can you tell us a little bit more about your graduate experience and where you went next?
Sure. So I grew up in Texas, and so moving to Berkeley was very different for me, but I loved it. It's a beautiful place if you ever have the chance to get out there. I originally went thinking I wanted to do small robots and actually got to do that. So I was pretty excited about that, but lots of ups and downs in graduate school. I think PhD Comics often has a comic showing the cycle of graduate school where you hit these pits of despair at various points.
Right. I've seen that.
And that certainly happens. And probably the biggest struggle I had throughout my career was writing that graduate dissertation, that PhD dissertation, because it's never what you want it to be. You have this great idea going into it of all of the things that you're going to accomplish, and you never get done with it.
Right.
So I think that was a huge struggle for me, but Berkeley's a pretty nice place to go through that struggle, I'd say.
Absolutely. And now can you tell us, as you were finishing up your PhD and looking towards your next step, what was going through your mind and what motivated you then to move on to that next step?
So my immediate next step was a faculty position, but I came into graduate school thinking that I would want to be an academic and teach and do research. And probably around year 3 or 4 of graduate school, I decided that was absolutely not what I wanted to do.
Really?
I wanted somebody to tell me what to do for a change.
Yeah.
And by year 5 or 6, I decided there were some ideas that I wanted to pursue. There were some things that I wanted to do. So I started looking into the faculty approach again. And yes, actually turned in my dissertation and hopped on a red-eye flight out to DC that night.
Oh, wow.
Then I started at Maryland shortly after.
That's phenomenal. So what was that transition like for you then, going straight from graduate school to becoming a faculty member?
I was pretty naive about the whole process. I remember sitting at my desk at one point thinking, what am I supposed to be doing right now?
Right.
You figure it out pretty quickly. It's interesting going to an academic position from graduate school, in part because really very little that you do in graduate school actually prepares you to do well in a faculty position. So the actual research and the kind of process of going through that research as an academic is often handled by your students, and you want them to get that experience. So instead, you're doing a lot of editing of papers, you're writing proposals, which is part of the research, is writing the proposal in the first place. But in teaching, you get a little experience as a teaching assistant, maybe as a graduate student, but actually teaching a class is an entirely different experience. You adapt pretty quickly, and I suppose you're in part hired due to your adaptability to these new scenarios.
Definitely. So now I know you have so many wonderful projects going on there at the University of Maryland. Is there one in particular, Sarah, that you are really, really excited about that you want to tell us about in a little bit more detail today?
Like you said, I have many that I'm pretty excited about at the moment. I can tell you about one that is mostly in our lab, although we have some collaborations around it. We're trying to study how you want to locomote, how you want to move when you are a really lightweight legged robot. So basically how ants move is one way of phrasing it. So we have a pretty good model for how everything from cockroach size, say 1 or 2 gram size on up, runs. So you can think of it as a mass on a springy leg. But when you're really small, that mass is nothing. You have no inertial forces really involved anymore. And your feet stick to the ground. And that stickiness actually is a pretty substantial force to worry about. And so we are experimentally studying this problem. And we actually make little legged robots from the size scale of 1 gram down to 1 milligram.
Oh, wow.
We actually have a running thing at about 1 milligram right now. And we can basically try different strategies of running this robot to see what kind of strategies get us better speeds, more adaptability to rough terrain, that sort of thing. So it's a super fun project. I love working on it. The student working on it is doing a fantastic job with it.
Well, this sounds amazing. So can you give us a little bit of background in terms of what some of the thoughts are for what these tiny little robots will be used for?
So a lot of the work we do is used for basic science. So we think of them as physical models for scientists. And the great thing about a robotic system is that I can change parameters any which way I want, whereas that's much harder to do oftentimes in an actual ant. Mm-hmm. So in this case, for example, we can work with people who are working on ants and trying to understand the biomechanics of very small insects, and provide these physical models to help them understand what's going on in the actual insect. We do similar things with some of our sensor work. So we work on soft sensors, and we work with biologists on trying to understand, for example, how moths get inertial data, for example, how fast they're turning. And we can print strain sensors effectively on a moth wing and try to better understand what's going on in those contexts. From an engineering standpoint, the idea of creating motors and sensors and mechanisms all in very small volumes and masses ultimately gives you a lot of potential in terms of medical applications. So if I can stick all of that through a very small catheter, I can reimagine how I do surgical procedures.
Very cool. Well, Sarah, you mentioned focusing on locomotor robots. I'm curious, have you ever dabbled in flying robots?
Very small dabbling.
Yeah.
So Rob Wood was a graduate school colleague of mine. Mm-hmm. He's up at Harvard and has done a lot of very cool stuff with robo-bees, as he calls them. So they're like 3-centimeter wingspan robots. So we do things a little bit. We've started playing with things at much smaller scale. So sub-centimeter wingspan. We use a lot of our fabrication techniques to start playing with that, but that's all very, very early stages.
Gotcha. And I understand you had a jumping micro robot as well. Can you tell us a little bit about that?
Sure. Jumping, I think, is a fascinating way to get around when you're very small. Mm-hmm. You kind of solve the same problems that you do by flying in terms of being able to get over obstacles, but you don't have the control and power problems that you do with flying. So this is something that I started doing when I was a graduate student. And it was literally nature inspired because I read an article in the journal Nature about the froghopper insect and how it was the champion of the jumping insect world. And I was reading through the force produced by its muscles in life, and I thought, I think I can make this. I think this is something that's actually doable. So I got started with jumping robots around then. I'm actually collaborating with some of the people who did a lot of that jumping insect literature very early on now in a project. And we're studying bio-inspired impulsive mechanisms and things that jump, things that smash. And we're once again doing a lot of creation of physical models to really understand what's going on in these jumping insects and how they're able to achieve the incredible power densities that they get for these jumps and other maneuvers.
Well, I think it's really interesting that you are looking to nature to get inspiration for some of these robots that you're building. And I'm curious, is there one maybe organism in nature, an animal that you've looked at and thought, wow, I really want to make a robot to emulate that type of movement?
Absolutely.
Do you have a favorite?
Probably my favorite is the trapjaw ant. And I've been kind of showing that in presentations for a long time. And the amazing thing is that I'm actually working with a biologist right now, Sheila Patek at Duke, who's studying the trapjaw ant. We're working with her to study these. And so these are, you can imagine them as typical ants. They run around like typical ants do, but they also have these effectively spring-loaded jaws, mandibles, that they can lock in position, and then they can use that to capture prey, or they can do a face plant on the ground and jump with their jaws.
Oh my gosh, this sounds amazing.
It sounds amazing. Actually, they showed a video of collecting them in Panama, and it sounded like popcorn going off all around you.
Oh, wow.
So it's pretty incredible type organism, but that's probably one of my favorites.
Well, it sounds like it is worthy of the title of favorite. I like it. Listeners, we're going to have to find videos of this later and look it up.
Yeah, they're awesome.
Well, Sarah, wonderful to learn more about some of the projects that you're working on in the lab today. And we hinted at some of the challenges that you faced along your journey, in particular related to trying to write this dissertation. And I think probably many of our listeners can commiserate with this experience. But is there another story of a challenge or a struggle that you want to share with us today? And tell us a little bit about how you worked through that problem to be successful.
Well, I can tell you how I worked through that particular problem.
Sure.
It was an incredible challenge for me. As I mentioned earlier, I think one of the challenges with a dissertation is that it's never what you wanted it to be. And I tried all sorts of different things to try to get that document actually written. I tried changing location. In fact, working outside ended up being the thing that helped me. And somebody pointed out that maybe it's just because you're not like stuck in the office and in this place that reminds you of what is not in your dissertation. Mm-hmm. So I think that helped me. And the fact that somebody pointed out to me at some point, and it's just one of these switch flips in your thinking, that a dissertation describes effectively a new frontier in research, kind of a whole new area. And why on earth would you ever consider it or expect it to be complete when you just kind of open up the door to this new frontier? So that, I think, just a change in the way that I was approaching the dissertation really helped me finally get those words on paper and get that thing turned in, which in the end, it's a rare thing that somebody actually reads it.
Right.
You want it to be perfect, right? And it's never going to be that way. So I try to hammer into my students that perfection is the enemy of the great or good all the time. But yeah, it's a challenge. I still have struggles with that.
I know I gave copies of my dissertation to my parents, and they're just in the little coffee table books that nobody opens. They just look at it. You don't open it.
I do occasionally get the random student at a conference. Oh, I read your dissertation, and it makes me kind of groan.
Yeah. So now for you, was the challenge in just writing up the results of your experiments, or did you have trouble with the actual experiments themselves as well?
I certainly struggled with some of the experiments. Actually, one kind of funny story from it was I was effectively trying to make little rubber bands and assemble them onto very tiny silicon hooks. And rubber, as you probably experienced, if you kind of drag it against something, it charges up and then sticks to it. Mm-hmm. So I actually had to buy a source of polonium to discharge my rubber bands to help me assemble them. And this was around the same time that the first Russian was killed using polonium. Oh, no. And I had just placed the order not even thinking about it as a radioactive, dangerous material. Mm-hmm. And I had to jump through so many hoops
to get this tiny amount of
tiny, completely safe amount of polonium. It feels a little silly describing my dissertation as trying to assemble tiny rubber bands onto silicon hooks, but that was effectively what it was.
Hey, it's a big challenge. It's a new frontier, like you said.
Exactly, yeah.
Well, Sarah, thank you so much for talking through one of these challenging periods. And I think you gave some good suggestions out there for our listeners who might be staring at that blank page on the screen in front of them, trying to get their own dissertations written. Take a step back, get outside the lab, just open your mind and get away from a lot of the things that are dragging you down in that stress of trying to be perfect in your dissertation.
Writer's block is a real thing, yes.
It is a real challenge, absolutely. But we don't just want to talk about the tough times, Sarah. I do want to talk next about some of your many successes. And I love celebrating these successes in science, whether they're big or small. So do you have a favorite story that you can share of yours today?
I think for me, it's a lot of small successes along the way. So anytime a student in my research lab graduates and goes on and does something amazingly cool, I consider that a pretty awesome success. Anytime a proposal gets funded, especially when it involves a new collaboration and new opportunities to kind of explore areas that I haven't before, I consider that a pretty fantastic success. The actual papers getting published, I feel that's the end of the story. It's the beginning of the story that's generally most interesting to me, and I consider the most successful. One short example, a proposal that got funded within the last couple of weeks was on studying rat whiskers, actually. So I am working with two collaborators at Northwestern. Mitra Hartman is the lead on that. And she's a mechanical engineer who does a lot of neuroscience with rats as well. So once again, these kind of role models that you look up to, really incredible person in all of the research that she does. I think just getting that proposal out the door even was a success. And you continue to be stunned at the proposals that are actually funded versus those that aren't. But of course, as a researcher, you think all of your proposals are great ideas. So, this was our kind of first time writing this up and submitting it. So we, similarly to what I've described before, are going to be doing some physical models of whiskers that we can basically run through a number of experiments and try to understand what's going on in rat brains as they see these same kind of whisking events that we'll put our physical models through. So I'm pretty thrilled about the opportunity to do that collaboration as well as make those sensors and do that kind of research.
Very cool. So what was going through your mind when you got the news that that proposal had been funded?
Wow, really?
Yeah.
That's awesome. That's pretty much what goes through your mind.
So do you have a traditional way that you celebrate these kinds of successes?
Oh, I do a little happy dance in my office.
Yeah. I wish we had video so we could see this happy dance.
Just imagine Snoopy, but more awkward.
I love it. Well, congratulations on this success. And I'm interested in this idea of rat whiskers. So what was it about whiskers compared to some of these other robots and things that you're working on that really attracted your attention?
So a lot of this came through Mitra originally. So whiskers are pretty incredible, and rats are pretty incredible at their ability to get around without sight, basically, and without vision that almost everything else relies pretty heavily on. And I'd say the idea of these physical sensors in general, I think, is pretty interesting to me. So strain sensors on moth wings and tactile sensors through rat whiskers, flow for sea lions, for example, through their whiskers. So there's a lot of very cool things that you can do just by sensing of mechanical quantities. The idea of being able to equip robots or devices with the ability to feel their way around, I think, is going to have a lot of potential implications.
I like it. Well, fantastic to hear more about this success. And we've chatted about some different aspects of your career and the projects that you're working on, Sarah, but I want to jump outside science again for a moment to talk a little bit about what you are reading. I love sharing book recommendations with our listeners on our program. So do you have a favorite book or maybe one that you're reading right now that you're really enjoying that you want to tell us about today?
I'm not surprisingly a fan of science fiction. I do read a lot, but I'm a fan of pretty much most, but not all, Neil Stephenson novels. And I think if I had to pick a favorite, it would probably be Anathema these days. Pretty fascinating imagination, has a scientific background, but I just love the imagination that you see in some of these books.
Very cool. Well, I will definitely add that to our list for our listeners to find there. And I'm curious, in reading science fiction, do you ever get inspiration again for your research? We talked about how you get inspired by nature, but do stories in science fiction help as well?
Absolutely. I think nothing that I've actually turned around into actual implementation, but in terms of thinking about what robots could ultimately do, what some of the microsystems that we work on could ultimately do, that's certainly inspirational and getting you up in the morning as well.
Well, great book recommendation, Sarah. And I think we've talked about some different aspects of your career in terms of the places that you've gone, some of the projects that you've worked on. But I love talking about the places that scientists get to go. I think there are so many wonderful opportunities to travel, either to work with collaborators at Northwestern or other places, or to go to conferences. So do you have a favorite trip or a favorite travel memory that you want to tell us about today?
Sure. I think they almost all revolve around conferences. Conferences are truly amazing for scientists or engineers in that you actually get to talk to other people working in similar areas. You get a lot of ideas, a lot of collaborations. It's just really inspirational. And so I suppose if I had to pick one, it would probably be my first conference because it also happens to be in a pretty nice location. Mm-hmm. Every 2 years, there's a microsystems conference at Hilton Head in South Carolina. So it's on the beach. It's a pretty relaxed conference as far as conferences go. They actually keep some of the afternoons open so that you can go enjoy the beach or play beach volleyball with your colleagues.
That's awesome.
It's a fantastic group there. People are so open, amazing, like talking about their research. And the first time I went was when I was a graduate student. I was very lucky in that I was not a first author on the paper, but they let me tag along anyway. And I remember just being so excited to get back into the lab after that conference because I was so excited about some of the ideas I had gotten while there and just really looking forward to pursuing them when I got home. So yes, I enjoyed the beach as well, but it was really the idea of talking to people and the ideas, scientific and engineering ideas that came from that I was most excited about.
That sounds like a wonderful experience, a great environment for your first conference as well.
Not Cleveland.
Yeah, right. Hey, I grew up in Cleveland. It's not half bad in the summertime. No.
Not a random hotel in Cleveland, let's say.
Right. So now, can you tell us, going into that first conference can be a little bit intimidating. Do you have any tips or things that really helped you make the most of it?
I think I was lucky enough to be hanging out effectively with people that the community already knew well, and they were very good at introducing me to everybody we came across. I remember just being stunned, getting introduced to these people whose papers I'd been reading for a long time, and I was like, wow, this person, they said hello to me. Yeah. So I think kind of linking up with somebody who's been around for longer and having them kind of show you the ropes is a fantastic way to do that if you have the opportunity.
Absolutely. Squeezing a little bit of networking. And I think these are great opportunities, like you said, to meet new people. And sometimes these people who you've sort of put on a pedestal and you've been reading all their papers and you can finally put that face with a name, I think is a great experience.
Yeah, sometimes they fall off the pedestal.
Right. That's okay. Well, Sarah, wonderful to hear about your early conference experience here. And I think some of the other wonderful aspects of careers in science and engineering are the great people that you get to work with. And I know there are a lot of stereotypes out there about both scientists and engineers, and we love to break those on our program because I think there are so many different, funny, creative, just amazing people working in all these fields. So do you have a story of your own that really showcases this human side of science and engineering, whether it's a quirky tradition that you experienced or just a funny or fond memory that you shared with colleagues?
Too numerous to count. Probably some that I shouldn't share in a more public forum. Let's see. One that I can share from my own lab, since I've been here at Maryland, is we do a holiday party that unfortunately was canceled this year due to rampant illness in my kids. But
oh, no.
We do a white elephant gift exchange, and the gifts that show up in that gift exchange are pretty entertaining every year. And so a lot of it comes down to, if you've ever done one of these gift exchanges, trying to make your gift, even though it's wrapped or in a bag or something, look like something that somebody really wants, even if it isn't.
It's all about the packaging. Yeah.
It's all about the packaging. And I think one year we had this huge gift, and it was pretty heavy too, and it looked amazing. And you could tell everybody was kind of eyeing that one. They really wanted that one. And this was brought by a Russian student. And it was two giant sacks of potatoes.
Really?
Which he was telling us, oh, you can make vodka with it. It's all good.
That is awesome.
There's often a lot of robot toys, which some people leave around after the party, which then get converted to my kids. So they like the outcome of that as well. But
that is amazing.
We like to celebrate. I'll leave the other stories under that title.
Well, I love this. 2 sacks of potatoes. Have there been any other really notable strange gifts that have showed up?
Almost all robot related, but actually robot was one of my older daughter's probably first 5 words, in part because of that party.
Oh, wow.
And she had one of those fish robots that she really loved for a while. So she put it in water, has a little flexible tail that it flaps. And it's very cheap from Radio Shack. We have like a $10 limit. Some people hand make things, which are pretty impressive. I give a lot of free conference swag,
right.
But lots of robots that are fun.
Well, this sounds like an amazing tradition and a fun way to share your love of robots with your students. I like it. Well, now we've chatted about some of the different work that you're doing in your lab, some of the amazing things that you're building there. And I'm curious, if we gave you everything, Sarah, oftentimes there are things standing in the way like funding or staff or technology or feasibility that keep us from answering the questions we really want to answer or tackling the problems we want to address. If we took all of the barriers out of the way, Sarah, and gave you everything today, what is the one thing that you would like to answer or build?
If you take everything away, I think probably the driving question for me, we have these incredible existence proofs in these small insects and even larger insects that are able to do these really incredible things with their mobility or what they're able to sense, what they're able to find. I want to figure out how they do that. So it would involve a lot of working with biologists, a lot of engineering. I want to be able to figure out how they do that and be able to recreate something like that.
Interesting. So what's the biggest barrier right now?
I think there's some interesting engineering barriers. So the way that biology builds things, right, with cells and tissue and like is something that's really hard to recreate in engineering. We can add a motor, we can add a sensor, but these are very discrete parts. And a lot of this is intertwined in the way we build biology things. Why biology is created. And so I think a lot of it comes down to figuring out new fabrication techniques, maybe that take advantage of some biology in how to effectively grow systems that could do the same kind of thing with that same tight integration.
I like it. Well, this is a really interesting topic to tackle, and I think we're slowly getting closer and closer over the years. Some of the advances have been pretty phenomenal.
Indeed. No, there's a lot of cool stuff that's happened, a lot of interesting scientific discoveries on the way insects do things, as well as a lot of engineering successes in the way we build things.
Certainly. Well, thank you so much for dreaming big with us today, Sarah. And we've chatted about different aspects of your career path throughout our conversation. And one thing that I love to give our listeners is pieces of advice that they can incorporate into their own scientific journey or their own lives. So do you have one piece of advice that you received at some point in your own journey that you want to share with them today?
Sure. I'd say it touches on the first question that you asked me of what I do outside of science. I think when I was visiting graduate school at Berkeley, so I was still a senior in college, I had one of the graduate students tell me that one thing you need to make sure you do in graduate school, and I imagine he was at one of these pits of despair in his own path, was to take at least a full day each week and do something different. So I think in general, the advice to take breaks is incredibly important. Let your mind relax a little bit. Think about something completely different. That's imposed on me in some regard with my kids now. I have to think about something different a fair amount of the time, but I think it's still incredibly important when you're in school to do the same thing, to take those breaks. Do something else that you like to do. It doesn't have to be related to school. It can be a sport. It can be hiking. It can be reading. Just take that break and take that time. I also don't do anything on Saturday nights. I had very bad experiences with equipment breaking, things blowing up on Saturday nights, so now I refuse to do any work on a Saturday night. It's bad luck for me.
Yeah. I like it. Well, you deserve to take Saturday night off, definitely.
Yeah.
Well, I think this is wonderful advice. And I think particularly when you're in, as you described, one of these pits of despair, you have to take a step back, because if you just sit there and kind of wallow in it, it can be a destructive experience.
Absolutely. There is a lot of constructive beating your head against the wall. Right. Don't get me wrong about that, but you do need to take a step back.
Absolutely. Well, thank you so much for sharing this advice with our listeners, Sarah. Is there any other last piece of advice you want to give them, or a last note of inspiration you'd like to leave them with today?
One thing I'd say, especially for students, is to not be siloed by traditional science and engineering disciplines. So I think one of the things that somebody pointed out to me at one point is I don't need to go on for a faculty position in electrical engineering. So a lot of the work I do was relevant to mechanical engineering. And I do a lot of work with biologists now. And so I like to tell undergraduates, especially freshmen who are interested in research, look outside of whatever department you've decided to park yourself in. Look to biology, look to computer science, look to other engineering disciplines. Oftentimes, faculty and labs in those areas would love to have somebody with your enthusiasm and skills that you have from this completely different area. So I think that looking outside of the box, letting your imagination run wild, all of those are important things to do early on.
Definitely. And I think these lines between fields are actually becoming more and more blurred over time as things are becoming increasingly interdisciplinary. So it's great advice.
Yeah, clearly I'm a fan of that horizontal innovation versus vertical innovation.
Well, I'm on board, Sarah. I think that's fantastic. So now, can you tell our listeners, if they want to learn more about you and the phenomenal work that you're doing, where should they go or how should they get in touch?
Sure. You can find my contact information on our lab website, which you can find with MRL, like microroboticslab.umd.edu. Or you can just email me at sarahb, SARAHB, @umd.edu. The one point that I will caveat that I will add to that is if you want a response, be persistent. Sometimes I get swamped in email, as many people do. And if I get your email for the second time, I'm more likely to respond to it. So if I don't respond within a couple days, feel free to email me. Again, I'm not ignoring you. I'm just underwater.
Sure. Well, I can definitely relate to that feeling. So listeners, same goes for me. If I don't respond, just keep emailing. I will respond eventually. So you're not alone there, Sarah. Well, thanks so much for sharing your contact information and how to get in touch with you with our listeners. Listeners, definitely check out that website. Sarah has some phenomenal projects on there. And Sarah, thank you so much for joining us today for an interview. It's been a pleasure to chat with you.
Thank you for having me.
Well, wonderful to have you with us, and listeners, great to have you here as well. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.